All right, let's get started. This is a really special kind of talk for us because for both of us, I mean, for me, it's the first developer conference in Greece that I'm doing speaking at, and I've been doing it for quite a few years. And for you, it's the first conference in Greece as well, right?
First one in Europe, actually. So.
And first one in Europe. Okay, and not enough. If that is not enough. Somebody, I'm not going to name any names, but somebody is having his birthday today. So,
yes, my joke is that my present is that I get to present. So.
All right, so let's get started with Java stuff. It's a really nice present to have, actually, on a birthday, isn't it? Yeah. So welcome to this talk. We're going to be talking a little bit, quite a bit, actually, about Dataframes, collections, and streams in Java, what it actually is, how you can use it, and all that. Before we talk more about this, I think it is time to say just a few words about ourselves. You get to start, Donald.
Yeah, so hi, Donald Raab. I'm a managing director and distinguished engineer at Bank of New York Mellon, based out of New York. I am the creator and a project lead of Eclipse Collections, which is an open source collections library, if you've heard of it. Java champion since 2018. I was a member of the JSR 335 expert group, which for those not familiar was the JSR that got lambdas and streams into Java 8. So it's quite an honor being on that expert group. And I was a contributing author to 97 things every Java programmer should know. So a little bit about me.
My name is Rustam. I am a chief engineer at a company called Computas. I live and work in Norway, so on the other side of the pond, really, from Donald. But we still did this talk together, and we managed to put it together, and have done it a few times. So I am a Java champion as well. I am also the Google Developer Expert for cloud technologies. I'm a Java 1 Rockstar. There used to be a conference called Java 1. There used to be rockstars of that. You know, it's a kind of still a title you hold on to dearly. I'm also community lead. I run a few communities back home and do all this kind of conference speaking and all this stuff. In addition, enough about ourselves. So let's talk a little bit about the problem. So what we're actually trying to solve. And because when you talk about collections and streams and data frames and all these things, you need to have something to hold on to, some kind of idea, some kind of problem. So our problem was that, look, if you want to process data, if you process data in, I don't know, tabular data like CSV files or something like that, or some other kind of data, you usually end up using some other languages, some other frameworks. I mean, I don't know, there is a bunch of pandas and all this kind of stuff, so you end up using something else than Java. And our point of this talk, at least one of them, was to try to show you, yes, it's possible, and yes, it's actually really, really nice, and it works really well with all the other bits and pieces of Java, so you don't really need to switch that. What we're going to use as a background data for our talk is, well, obviously it's a conference data about places we talk, about the conferences we speak at, you know, all this kind of stuff. We just chose a little set of that for, I think it's like the conferences that either of us were, either me or Donald were speaking at until this summer or so. How can we do it in a more efficient way? We want to talk a little bit about that because it is, you can have two different approaches, and you'll see that. You have an approach as a programmer, as an object-oriented programmer, so you do object-oriented approach where you create your own domain, your own classes and objects and all that, and you do stuff with that, but we also want to show you that it's also possible to work with tabular data, like I said, like for instance, as you would do in pandas or something similar. So, what options we're going to be looking at? We're going to be looking at the built-in one, the batteries included version of something that is called Java Streams. We also talk about a library called Eclipse Collections, and the father of that library is standing next to me. And also we'll be talking about something that's built on top of that, which kind of works more on the tabular level that's called Dataframe-EC. So EC stands for actually for Eclipse Collections, so it's built on top of that as well. The libraries we're going to be mentioning, the language obviously is going to be Java. You do not really have to be an expert in Java or anything else to follow this, and you should be able to find similar things in different other libraries, in different other languages, because, you know, things kind of usually intertwine. We're going to show you what you can expect from libraries like that. Right. So, example data. So this, actually, the whole presentation is done in IDE, and we're using ASCII-Doc to generate all that. And this was one of the really nice features of that. This is actually CSV data. If you go into the source code for that slide, it's just CSV that's pre-printed as a table. But this is the data that we need to work with, right? We have a bunch of conferences with event names. We have a country where that is taking place, a city, start date, end date, and the session types. So, you know, what do you have? Do you have only talks? Do you have only talks and workshops? Do you have something else? Is it an conference? You know, things like that. Right? So this is our test data. And start date, end date, we're going to be using that quite a bit later as well. And the question is, like, what to choose?
Yeah,
I guess that's over to you.
Any fans of Lego out there? All right. I have two old kids now. Well, they're adults, so after 18 years of buying Legos for my son and, well, for the other kid in the house, myself. And actually, my wife likes Legos quite a bit as well. So we have so many Legos. I think like 20 probably crates of Legos in our basement after 18 years. But so the nice thing would be like, hey, yeah, it'd be much better instead of building software that, hey, we could just build with Legos. It'd be fun, right? So, so taking this inspiration from Legos. So we wanted to have an analogy for you all to walk away with today that, you know, looking at these different frameworks, how would I think about them? So we looked at them in terms of Lego brick systems. So how many people are familiar with the classic Lego brick system? Yeah. Most people. Lego Technic? Okay. Lego Mindstorms? Good. Okay, a few. So just think with the classic brick system. Obviously, there's a lot more sets out there. It's really targeted towards younger ages. You know, after 9. I would say the youngest brick system is the Duplo system. Anybody have Duplo? It's okay. You can admit it. Okay. I probably had some a long time ago, but that's for really young kids, right? So the classic brick system more targeted towards 9+ age. And we looked at Java streams as kind of a good analogy with the classic brick system because you got basic building blocks. There's some assembly required on your part, but you get a lot of the low-level control of handling data and stuff. So looking at Eclipse Collections, we thought that a good way of describing Eclipse Collections, it's a very comprehensive library. There's a lot more types. You have things like support for object collections, primitive collections, immutable, mutable, readable. So you have a lot more types. You have a lot more methods available on the collections themselves. And it's been optimized, started out in banking. At the time it was created, I was working at Goldman Sachs. So we were using it in large caching systems that we built. And we wanted to have like memory efficient and performant code in our collections. And it's going on, I guess, like 19 years old now. We looked at it based on its size. It's about 1 million lines of code. Don't worry, I didn't write all that. A lot of it's code generated because when you want to do primitive collections and you want to support all 8 types, you use code generation. But so it's still compatible with the basic building blocks. So if you're familiar with Java collections, Eclipse Collections implements the same types, at least for the mutable side. But because it's much more comprehensive, has a lot more things to learn. We look at it as like it's really targeted towards, let's say, maybe an older age range, which is kind of equivalent with Lego Technic. You got more custom pieces, you can build bigger things with it, more optimization, so on and so forth. Now with Dataframe-EC, which is one of the the Dataframe library that we decided to take a look at. Similar to like Lego Mindstorms, it's got like a programmable brick. You can look at the data frame itself as something that you program. You can add features to it and whatnot. It's got these specialized building blocks, but it's actually built on top of Eclipse Collections. So similar to like with Lego Mindstorms is actually built on Lego Technic. So it uses the Lego Technic pieces, and it adds the programmable brick. It adds sensors that you can program, so on and so forth. So we thought that was a good analogy for this, for like something that's building on top of something else. So it is still compatible with the basic building blocks. And yeah, you can program it to do different things. We're going to be showing you some of that today. So
And notice the age differences. I mean, this is actually, we just pulled that off the box, like age 9 plus, 16 plus, and the other one is like 10 plus. So, you know, we thought it was a really nice analogy to show you a little bit of a complexity. I mean, well, obviously that does not apply to the libraries, but it shows you the idea.
And I just turned 17, so I can use my own library now.
Yes. How many years experience? Okay, let's don't go there. So, Conference Explorer, what is that thing?
Yeah, so basically, as Rustam was talking about before, we had this problem we came up with, which is we want to ingest, conference data from a CSV file. And what we needed to do is, like, at least for the object-based solutions, which are Java streams and Eclipse collections, we needed to have some domain model defined. So we decided, like, we'd actually use new feature as of Java 14. We were actually, for the code that we were actually writing using Java 20 with preview features turned on, so you'll see some of the preview features we're actually using in here. But basically we decided, let's use records to define conference. So we defined a conference record. It's simply got an event name, a country, a city, the start date, end date, and then the set of session types. So it's very similar between Eclipse Collections and the Java Stream solution. They both use a conference record. So in the, we define this little helper class called the Conference Explorer, and a Conference Explorer holds on to a set of conferences and a set of countries. We decided for our use case we wanted to use immutable sets. So in Java, there is no immutable set interface. We just use the set interface, but we have the set of conferences, set of countries for the Conference Explorer and streams. For Eclipse Collections, there is an immutable set type, so we define it as that. So you can see there's an immutable set of conferences, immutable set of country. Now with Dataframe, our Conference Explorer, since Dataframe, you don't actually use your own domain types, it gives you this tabular data structure called the Dataframe. That's actually what you keep around for basically the conferences and the countries. They're just data frames themselves. So what we wanted to do in the course of the use case we were exploring with the reading and the conference data, we want to read in the data. We want to do different types of processing against it. We maybe want to group the data. We want to count the data. We want to sort it. We want to sum it. We want to get unique values. And then it's not interesting enough to just to process data. We actually then wanted to output something. And we were ingesting CSV. We wanted to then output JSON, which is, I think, pretty common for folks these days if you're dealing with services and whatnot, a JSON common output. So. Okay, so the approach we took, and as Rustam said, he's in Norway, I'm over in New Jersey, and as we're working on stuff, like we're working on the code together, we said, okay, let's establish tests, and actually then we can verify, like for each of the solutions, we want these tests to run, and then the solutions that we implement, passing all these tests. We have a test for each of the different processes that we want to do. There's the loading of the data, there's the grouping, the summing, the counting, different options. So we have tests for each of those things. So they're equivalent across all the solutions, so that when you're doing a comparison, we give you the repo link at the end, you can actually then look and see what are the differences in terms of the code between the solutions. So, and you can see that these are links to the actual test cases themselves from the slides. So, with that.
All right. So first thing we do, we actually need to read that data in. So we need to ingest the data, and as you can see, there is a lot of kind of boilerplate stuff happening. So in the beginning, the first couple of lines is more like you define schema, you define where the path is for the file, and all that kind of stuff. So what usually, what is probably the most interesting part here is the part within the try catch. Well, there is no catch, but that's not a pun. That is just a short and tiny little piece of code, which you can actually see the whole thing you can see here. So the slides are actually linked directly to the code. So what you can see here is what happens is that we need to use Jackson for both of the first two options. For both Java streams and Eclipse collections, you need something to map. You use Jackson to map that into objects. Otherwise, apart from that, it's kind of more or less similar things happening, except for that we need to have some kind of initial filter. So in this case, we define a year for 2023 as a year, and we define that as initial filter. And we have a little function that we had to create ourselves called create conferences from lists.
Yeah, so for both solutions, it's effectively you just have a predicate defined for initial filter based on the year.
Same thing happens again in Eclipse Collections as well, more or less the same. And what happens with the data frame is a little bit different. So here we actually have, and again, I mean, it is a library, yes, and it's there are several other libraries out there, but usually you do expect, as those that work with tabular kind of data, you expect the function to be there that read a CSV. And there we have that one as well. So you do a new CSV data set, you define the URL and path and everything, and it just appears there magically. What is worth mentioning here is that we can actually add more functions like Donald mentioned already. So since we do not have any domain objects and domain classes and domain structure, we need to add all our smartness into the table.
Yeah, so I guess like on the object side, where we had the domain object called conference, we can add methods to that object.
Exactly.
We have no object to add to, so what we actually do is to attach, if we want dynamic functionality, let's say a calculated column, we attach a function to the data frame itself to actually define that column. So that's what's going on there. And we have a few dynamic columns that we're defining.
Yeah, you'll see quite a few dynamic columns that we'll be adding as we go, but here we also define the filter, but here it's a little bit easier. So right, you just say select by and then initial filter. Again, initial filter is just a string of 2023. Next thing is, so let's do something, right? We've ingested data, we need to do something about it. First thing we want to do is to sort. That's a typical thing. You work with data, you work with, I don't know, SQL or any tabular libraries or anything else. You want to sort things because, well, that's what we do usually with data. We sort it by something. Here we decided to do sort by days to events. So you kind of do the countdown, how many days are left to the event. We have created a little helper function that is defined all the way up there. Days to event that returns number of days as a long. So what we have here in both Java streams and again also with Eclipse Collections is more or less the same thing happening where you create a stream, you sort it, you provide a comparator, and you need to provide a function that does the comparison that actually returns the values that you can use to compare. And then at the end you just pack it into a list.
And what's interesting, I guess, like if for those who use the Java streams in the audience. Okay, have you used Java streams? I guess as of Java 16, there's a new toList method on stream. Have you used that? Anybody know what toList returns? It's an immutable list, that's right. So if used before Java 16, if you use collectors toList, it actually would return an array list. In Java 16 plus, if you do toList directly on stream, it is returning you an immutable list. So still, the list interface, but it is optimized and it gives you some interesting benefits in terms of performance. So we didn't measure that here, but thought it would be interesting to point out. With the Eclipse Collections solution, what you can see is a very specific method available. There are converter methods to both mutable types and immutable types on every collection type. So we can take the set of conferences and just say we want a two immutable sorted list by and pass in the function.
So you kind of jump over a few steps, but it's basically the same thing, right? It's sorted and toList, but just in one go. With Dataframe, it's a little bit more different, right? You need to, it's tables, it's tabular structure. You need to create our own so basically exactly what happens up here in a function, we need to do that in a kind of built-in function. And what we do here, we create we create a function, we attach it onto the data frame, and we call it what it's going to be. So we call the column days to event. That is going to be calculated on the fly, and we also have a tiny little DSL that we create and define ourselves, the function called days until, and then you provide a start date. So it counts from now till start date, how many days are in between there. And the whole function days until is in here. So you define the function, and then at some point later in the code, you get to use it.
Yeah. And what you get to see here is if you look at the code, see where it says chrono unit days between? It's pretty much the same code that you see in the method, right? Yeah. So,
but the idea is now you need to move your logic out of your domain objects into tables. I don't know, I usually think of it as tables, and I usually map a lot of things to SQL, so just so you know, if I say some kind of SQL stuff, you know what's happening in there.
Sorry.
Yes, go back.
I don't understand if the JSON feature is an embedded feature of the data frame.
It's not. So we're actually defining days until as the function right here. So this is actually adding a days until function, and then we're adding a column called days to event, which is actually using days until.
So you do add function descriptor here, and that's where you actually call it. So this is the name, and this is how you refer to it later.
Yeah. So it's like we had to add that more generic function called days until, and we're actually specifying then use start date with days until. So.
Okay, got it.
Thank you.
Well, that's good question, because probably more people wonder about that.
Yeah, so next thing that we wanted to do with the data, we wanted to group it by something. So we decided like, hey, let's group the data by country. And what you can see, every conference on the domain, on the record we defined for both Java Streams and Eclipse Collections has a country, accessor, which will give you a country object. And what we do with Java Streams, we do the standard like, take the set, do stream, do collectors grouping by. Now what we wanted to do specifically is we wanted to, as much as possible, keep the data coming out of operations as immutable. And so we used collectors to unmodifiable set. There is no toSet method on stream itself, so we have to use a collector here, but we wanted to have the immutable type come back. With Eclipse Collections, what's interesting is because the methods are directly on the collections themselves, they're covariantly overridden for different types. So we're looking, if you recall, Conference Explorer for Eclipse Collections had an immutable set for conferences. So immutable set knows that if I do group by, I can return a specific type, and in this case, for an immutable set, I want to return an immutable set multimap. So it gets very specific. You can get more generic. You could, let's say, type it as set multimap or multimap because it's defined in the type hierarchy. But the point here is like you have methods directly on the collections. They have covariant overrides to return the most specific thing for the type that you're looking at. So it becomes simply that I do conferences group by, give the country, and I get back this immutable set multimap. With the stream solution, it was coming back with map of country to set conference. The interesting difference between these two things is that the map itself is not null safe, right? So if I look up a key that doesn't exist, what do I get back? I get back null, right? Mm-hmm. So with Eclipse Collections in a multi-map, if I look up a key that doesn't exist, I get back, in this case, an empty immutable set, right? So it is more tolerant of null behavior. You don't have to protect against it. You're at least always going to, again, get an empty set back. Now, with Dataframe, doing group by is interesting because there's no multi-map, but there is a type called df-index. And what we do on the data frame itself, we call create index, and we say what we want to give the index name. We call it country, and we give the attributes that we want to actually index on. So in this case, we're going to index on the country column. And then we, once we've created the index, we actually then return the index calling this conference's index. I won't jump into it now because we'll spend too much navigating. But if you go into the test itself, actually, you know what? Let me take it back. Yeah. Okay, there it is. We're there. I was looking at group by country, right? Mm-hmm. Okay. Yeah. So what you'll see here is like for group by country. This is the test code that we're doing. And what we wanted to do is validate based on the group by that we can actually find Greece in the type. Now it's interesting with this particular API, and this was one of the benefits of working with a library where you have an open source maintainer who's very kind to requests. So we actually requested of the developer, his name is Vlad Zakharov, this particular API that makes it easier to deal with df-index. So what I wanted to do is like find the, do the group by country and find at the, key of Greece, look at the values that are in there and assert that we actually have Athens for one of the conferences, right? So this was actually new API as we were working on this talk. Vlad actually added for us to make it more simple. We could have written it, with a little bit more complexity, but this made it somewhat easier to write. So. There we go. Okay, so that's group by country. The next one, I'm not going to cover this too much, but group by city, very similar. It's going to look the same structurally code for both, actually all three options, right? So you can take a look at that separately. The next thing, though, we wanted to do, we did group by, which gives us back, let's say either maps or multi-maps or DF indexes for DataFrame. Doing a count by, let's say, an attribute. So in this case, we want to do a count by country. With Java streams, what I would do is do, stream, I do collect, collectors, grouping by, and then I use a downstream collector called collectors counting. And this comes back with a map of some type to long, which is effectively the keys to some count. So some interesting things happening here between, let's say the difference between Java streams and Eclipse collections. With Eclipse collections, you come back with a different type. Now this type doesn't exist in the JDK, it's called a bag. Is anybody familiar with a bag? Okay, a few people up front. So bag is like my favorite data type, and it's because I'm a Smalltalk developer. I grew up with bags way back. Anybody remember the 90s? Okay, I'm the guy with the birthday, so I'm old, sorry. 25, okay, max 25. But anyway, so we have a bag type in Eclipse collections, and a bag is basically, it's an unordered collection that allows duplicates, right? So, and it looks like a collection from the outside, so you treat it like if you want to add things to it, you say, like, if I had a bag of fruit, I would say bag, add banana, add apple, add apple. But inside of the data structure, it actually keeps, let's say, a map of a key to a count. So it's very good for counting things, right? And there's a specific API on it called occurrences of. So when I do this conference's count by, and this very specific method always returns a bag. You can see I just specify this function via method reference that I want to do the counting by. And if I did occurrences of returns an int, right? So if I do occurrences, and this is a similar story that we had with group by. Remember, if I did a lookup of a key that didn't exist, I would get back null. Same problem with counting in Java. If I look up a key that doesn't exist here, I've got to handle the null case where I could get back a null value, right? Whereas with the bag type, occurrences of, if it's not in there, it's going to return 0. Right? So you don't even have the option to deal with null because it's not an object type coming back. It actually comes with the primitive. Now with counting in a data frame, we have to do a little bit more work here. We use a method called aggregate by that's available on the data frame. We say like we want to use an aggregate function called count. We give it this name of country, and then we actually give a calculated column of country count, and then we're specifying what we want to aggregate by, which is the country. And what this will effectively come back with is something that looks like this. And this is one of the neat things. Okay, we got it right here. Yeah. So you can see when we're doing the test data here, we actually construct a data frame quickly, in memory. So we just say we want to have a column called country, a column called country count, and we can add just the rows to the data frames. We add the countries and then their long values, and we can actually validate then when we call count by country that we get back this expected data. So
one of the funny things is that actually the data frame compare function was hidden well deep into the tests of the data frame. And then we realized it exists, and we're like, can you please, please, please move it and make it available, because this is like super nice and super useful for writing tests outside the function. And that was another feature that got really implemented.
And I would say that is another great thing, once again, working in open source, right, where you can actually interact with the people who are, working on the library, ask for features, right now.
Or implement features yourself. I've implemented a few small things that contributed back. There are a few things that we'll talk about in a bit that also has been added, but not really pushed yet because we want to restructure it a little bit, but we'll get back to that. So summing conference days by country. So now we want to do a little bit more advanced things. We've done group bys, we've done sorting, we've done all that. But now we want to do like two things at the same time, because you see that we do group by first and then we do sum. So it's two different steps. In both Java streams and Eclipse collections, it's pretty much similar, right? You use, for the streams, you use a collector, you do group by country, and then you also provide a comparator, or well, a function that, sorry, not comparator, but a function that returns a number of days that you can actually sum by, a pointer to that function. While in Eclipse collections is just, again, it's a bit more condensed into one thing saying samba long, you do a country, and you also provide a pointer to the function again that
Yeah.
provides
I
you
think
some.
one primary difference here, though, as well, is like in the case of streams, you're coming back with a map of country to
Yeah.
the long sum, right, which is a capital L long. With Eclipse Collections, sum by long, and there's four, I think, different sum by methods: sum by long, sum by int, sum by double, sum by float. Comes back with a specific primitive collection. So we have primitive maps in Eclipse Collections, so you can see it comes back with an object long map. Now, it's interesting because like with an object long map, you're going to get a similar type behavior. If you look up a key that doesn't exist here, you're not going to get back null because it's not null values. They're little L longs, right? So it's actually going to be a 0, right?
Okay, we got just 10 minutes warning
Yeah, okay.
now. All right, so this is a bit more fun. You add a bit more complexity to this thing. And this was probably the first custom function that I've implemented on the data that I was playing around with. That was because we wanted to create emojis for each country. So we wanted to create a distinct list of countries, unique list. You see, I'm still talking in SQL. So what in SQL would be typically distinct, this is what the unique list of countries would be. So you do all the countries, just the one set of those, and I want for each country, look up its 2-letter code, and for that 2-letter code, I want to generate emojis. I can talk about why you need the 2-letter codes.
Does everybody know that you can generate emojis, flags from 2-digit code? Because I didn't know that until we were doing this talk.
You can, we'll show you a link at the end. I mean, we can talk about that later. Yeah. But there is a fun thing. You can actually generate emojis based on, things.
Oh, cool.
All right, so here, what do we do here? We do a map and collect to unmodifiable set, but because in there, that information of 2-letter codes is already in the record. Same goes with Eclipse Collections, which is a tiny little bit different, but still very similar. It's kind of recognizable pattern there as well. You still use the smartness of the record called conference, or no, country actually, the object, the class country. And for Dataframe, it's a little bit different, so this is a bit more fun. So here you do actually joins. So first you have a Dataframe of all the conferences with all the countries where they appear or take place, and then you have another Dataframe with only a list of countries with all the 2-letter codes. Now you need to do a join of those two tables together, Dataframes. And then this is how you do that. So this is the match, is like which column you match to which column in each data set. You create a column called alpha to code, and if absent, well, it's a nice feature. If you don't get a match, you get to choose what it says. So in my case, it says unknown. And then you actually create another DSL, so it's here. So it's another function called toFlagEmojis that does all the smartness of generating the emojis based on the codes. All right, so real quick, talking about outputting this stuff to JSON, because we wanted we didn't want to go with CSV, we wanted to go with JSON because, well, nowadays this is what you usually use for, as a backend, serving something to the front end, and, or something like that. You might want to go with JSON, and it was a little bit different as well. In both cases for Java streams and Eclipse Collections, again, you would use object mapper, pretty standard. There is it's a known data structures, it's known data structure that you kind of converted to, which is JSON, so you just pretty much use the standard available things.
Yeah, I would say just like in this particular case with Eclipse Collections, for those that haven't seen Java 20, and I guess it's on the 4th preview, this is actually pattern matching for switch. Yep. So remember I described bag before, where you say add fruit to a bag, right? Add banana. The problem with like a bag from a JSON perspective, it's a collection, so when I output it to JSON, it's going to take the fruit and one by one output it, because that's what it looks like. It looks like a collection outside. You don't actually get to see the internal representation. So I'm using pattern matching for switch here to say, hey, if the thing I'm outputting is a bag, actually output it as a map of item to count. So I can actually then have the, just apple and say 3, or banana and 2, or whatever, right? So, so this was actually useful here to just experiment with that feature. Worked fine. And
for the last one, since it's a bit less known kind of data structure, and it did not have its own object mapper implemented, I had to do that. So if you ever wondered, have you ever written your own object mapper for Jackson? No? Well, a few hands, good. One, I think two. Well, two, yes.
All right.
So Mario is actually holding up two fingers, so I guess he did it twice. At least. At least. Yeah, so in case you wonder how you do that, this is a kind of a preview, a little bit of a taste how you do it. It's really simple once you've done it. In the beginning, you're just like, oh, what do I do now? It's quite fun. Let's go into pros and cons because we're running out of time.
Yeah, I was just say real quickly for streams, right? One of the biggest pros is just built into the language. If you're using Java, like you've got streams available. They continue to evolve the library, so they're adding new methods, with each release, it seems. And what's cool as well is because they're evolving the language quite a bit. And one of the things we wanted to explore in this, experiment and then talk was that, data-oriented programming in Java does not suck as much as it used to, right? Because like a lot of the boilerplate has now kind of like evaporated and they've made things a little bit more pleasant to deal with. So we wanted to show like, hey, there's not a lot of, you didn't see a lot of code here, right? Maybe the JSON stuff was a little bit more involved. But large pool of resources out there, you got lots of training. It is open source, you can always contribute to the JDK, you just have to build up some credibility and you have to sign the Oracle contributor agreement. Some of the cons, like slightly more verbose, right? You do have to deal with things like the null safety when you've got methods that are returning maps like group by or counting or sum. And it does require the Jackson dependency. So with Eclipse Collections, you get this rich and concise API. It is, got a lot of methods. It's got a lot of extra types. It does have types that then give you better null behavior. It has the primitive collection support. You saw the one primitive map that we were able to use here. There's less, let's say, you won't go to probably find a plural site class unless I go build one or, some other training thing, but there are lots of katas out there to learn and documents, and I do blog quite a bit about it, so that's always out there. It's open source at the Eclipse Foundation. You can contribute to it. Similar, you do have to sign a contributor agreement. You have to sign the Eclipse contributor agreement, but we welcome contributions. Downside, it requires a third-party dependency, and a lot of people don't want to take a third-party dependency. It's like you got to have a real need for it, right? How many people know Eclipse Collections? Just, wow,
nice.
All right, a few hands, right? So that's good. So less skilled resources, but they're out there, right? So it's nice to see. And similarly requires Jackson, or some JSON library.
So Dataframe, well, it is, again, it's rich and concise API. It has built-in support for things like CSV and all that. It has flexibility, so you can actually define your own stuff to create whatever you want with your objects. You can just attach, like we've seen, you attach more logic and more smartness onto your DataFrame object. It has built-in DSL. It has some really basic stuff, plus and minus and times, multiply and all this. You can create your own functions, as we've seen. You can do a lot of this kind of things that are that make your life a little bit easier again. It has Eclipse Collections dependency, so if you need to do some Eclipse Collections, so a little bit low level or a bit more hardcore stuff that is not available in Dataframe, you can actually do that. And it's also very helpful open source maintainer that is out there that is really welcoming to things, and you can submit feature requests or submit some pull requests and all that, and it goes pretty smoothly. And I really enjoyed doing that. I enjoyed submitting some pull requests and everything because I actually learned quite a lot while getting that thing approved, because you don't get it approved right away. No, you do, but there is a lot of discussions on like if that is a good feature or not and this kind of stuff. So there is a lot of good thoughts lying behind all that. So when it comes to cons, it's a bit more. It's yet again third-party dependency. Now we have at least two. It's probably less skilled resources available. It's still minimal, so it's easier to learn, but yes, there's less people know about it. And it's probably less mature. Well, it is less mature and evolved compared to other Java alternatives like TableSaw, for instance.
Does anybody use TableSaw?
Anyone?
So it's another DataFrame library out there. And similar, it's interesting because like TableSaw is actually built on another collections library that is primitive collections called FastUtil, I believe. So anybody use FastUtil? Oh, wow, more Eclipse Collections users.
Well,
Awesome.
More stuff to learn.
Okay.
All right, so real quick summary.
Actually, you can take a picture of this real quick if you want as well. That's the URL to the...
the bottom there
talk.
is the actual URL to both presentation and the code and everything in one. Yeah, so data-oriented programming is actually possible and easy to do in Java. You don't really need to switch to any other languages. The features that you need will kind of dictate which one of the libraries that you need to choose, but now you know what you can, what you can expect in different approaches. We've played around with quite a few things, and we learned some things, or we used some of these things just to show you how to use it, like Java records, pattern matching have been mentioned, Java time, all those kind of things, and also some surrogate pairs. If you want to learn how to build your own emojis out of characters and stuff, look up surrogate pairs. And well, ASCII-Doc and all that, because we've built everything. The whole presentation is ASCII-Doc. And this is our link to the presentation as well, at the bottom there. Some useful resources, there's no really point.
Well, if you go to that link, you can find out these links, right? So.
And that's pretty much it, all we've got. And do we have any times? Yeah, time's up. So we can do questions outside. And if you want to find us, this is us on the Bird network.
Yeah. I would say thank you, everybody, for coming today. It was great to see you here. And
thank you very much.